Okay, last time we introduced you the idea about static variables. Let me review very quickly because you need that for your lab test, at least a practice test. Okay. So now let me just recap very quickly, and then we'll go through the example again to make sure you understand what's going on. Whenever you declare attributes for your class, you got two choices for each attribute. It can be static or it can be non-static. I would say the most common cases are you simply just got non-static. Okay, let me just give you one example. If I say class, I'll just call it C, just for simplicity. If I got class C over here, and let me just give you two examples over here. I can say integer I. Okay, so this is pretty much what we are used to before we talk about static. Okay, as soon as you got any declaration like this, it's a type for I, and you don't see the keyword static over here. So that means this is a non-static variable. As soon as you see non-static, the way you visualize it will be different from static variables. So we'll see. Okay, let's review very quickly. If you actually got, let's say, non-static variable, how can we visualize it? That means every object that's instantiated from this class is going to have their own copy of this variable I, right? For example, I might have C1, which is an object of type C. And then that one there is going to have a separate, let's say, type C over here. And then you simply got I over here. Default value can just be 0. And also you got C2, just another object of type C. The same structure, but now I, just a separate copy of I, can also be 0 to begin with. You can have as many instances as you like for class C. Okay, guys, please. All right, so now for the attribute here, we got two separate copies. So you can say C1.I versus C2.I. They simply refer to different copies of the integers. Okay, that's what we have talked about so far. Okay, until last time, we actually now introduced the keyword called static. How do we understand it? The principle is easy. As soon as I see the keyword static over here is a keyword, you should know, in Java, and then I see integer j. So now this j here is declared also as an integer. The fact that it is of type static has a very different meaning. That simply means not every object has their own copy of j, but all the objects share the single copy of j, a single copy. Okay, let me write it down. So what we have right now is whenever you got static, so that means all objects of type C share a single copy of j, which means every time you modify the value for j, it's going to be visible to every other objects for the class, right? If I only modify, let's say, C2.I from 0 to 2, for example, it's only visible over here, right? It wouldn't change C1.I, it will be unaffected. But for static, it's global, so it will be affected. Okay? That's a very quick summary of what we said last time. But let's now revisit the example. I'm going to do it on the iPad to make it a little bit more understandable to you. But you can definitely try the source code I'm going to make available to you. Let's switch to this example over here, which we talked about last time. Let's see what we have. Let's make it a little bit more concrete. We have a class called counter. Okay? By the way, in the lab test, you don't have to worry about the keyword public. Every class will be in the same package, unlike the lab exercises. So every time, you can just ignore the keyword public. It wouldn't hurt to put it, but you'll be okay if you don't put it either. So now we got two variables over here. You can see the first one, integer L, standing for local. It's non-static. You don't see the static keyword in front of it. So that's non-static. On the other hand, the blue one over here is static. Okay? Syntactically speaking, you can see the keyword static over here. So that means every object of type counter has their own copy of L. And all the objects of counter is going to share a single copy of G. Okay? Which is reviewing what we just said in the previous page. And typically for static variable, you just initialize it as soon as you declare that, just to have some initial value. Whereas for non-static variable like L over here, you only initialize it in the constructor. Okay, and there's another difference. That's typically the case. Let's have a look at two mutated methods here to see. Basically, this mutated method here is simply just going to increment the local variable for the context objects. You can think about this is as if we say this.l plus plus, okay? That this is simply implicit. I believe one of you guys asked me the question on the forum to clarify this. If you find that explanation not sufficient, let me know. I can try to explain further, but I think that should be clear enough from the tutorial videos. The second mutated method we have over here, okay, that one is going to increment g over here. Okay, you can think about g does not necessarily belong to any of the particular instance. It belongs to the class, okay? You can think about whenever we got static variable, g, you can think about it belongs to the class. Okay, belongs to the class. Let's see how we can manipulate these two variables. Okay, have a very simple example. Basically, we're going to do the following. Let's just visualize what's going to happen in these two lines quickly. Okay, we're going to create counter C1 and C2, right? So now each object for counter should only contain the non-static variable as we just said, right? Let's create that very quickly, okay? So everything else will be simple. So now let's say C1 is now pointing to a counter object over here, and also C2 is also pointing to a counter object. Now, what attributes should we include in the counter objects? All the non-static attributes. In this case, only L. Okay, that's the principle. L over here, initially, is simply just 0, right? We're going to assign L to 0. Okay, L0 and also L0. Okay, so far so good. One more thing to mention. Since now we also got static over here, which with the initial value 0, the way we visualize it is not to include it as part of any of the objects. We're going to set it aside to say that it's going to be visible to all the other objects. So this is what I would do. What I would do is I'm going to put in blue over here. So this is a separate place. I'm going to keep track of all the global or static variables. In this case, we just have one. Okay. So now all the I'm also going to put a counter here. It's not really an object, it's just a placeholder. Okay, just for housekeeping. So now it's going to be G, and then initial value will just be 0. Okay, let me say it again. So these are all the static global variables of counter. Okay, the word global is really important, which means globally speaking, the value may be changed by any other object, but we will see. Okay, so now we do see the distinction between the static versus non-static. Okay, orange versus blue. Okay, so we are done with these two lines. So now basically what we're going to do, we're going to execute this block of code for multiple times between the updates. So that's what we want to see. I'm just going to repeat just once. Okay, when you download the source code, you will see the complete picture. Let's see how we can inquire about the values for these two variables. Okay, the L over here is very simple. It's just the way it is. Okay, so now let me highlight it. You can simply say, for example, C1.L and also C2.L. At the moment, they're simply both 0. Okay, that was easy. Now, how do we get access to the global variable? There are two ways for you to do it. Either you can just use a normal way. You have a context object, either C1 or C2, and then .g. That's allowed. Okay, I'll point it out first. So over here, you have basically C1.g, C2.g. Okay, let me write it down here. Basically, when you have, let me have a blue over here. So these two over here, so this will be allowed, but not common. Not common in the sense that conceptually, the variable g is static, which means it should belong to the class counter rather than belonging to C1 or C2. Okay, so even though this is allowed, but I would say it's not common. Okay, what would be the recommended way to write it to really conceptually to be separate? The way to write it would be like this in the green, counter.g. Okay, let me write it down here. So when you say counter, which is the class name, .g, we're going to see more examples maybe sometime next week when we talk about API in Java. Every time when you see the dot notation over here, but to the left-hand side, it's not really an object variable name. It's simply a class name. Okay, you can see counter over here is a class name. Whenever you see a class name, that simply tells you whatever that's to the right must be static. In this case, indeed, G is static. Okay, syntactically speaking, it's more recommended you try to access the static variable using the class name. Okay, so now what would that be? Well, as we can see, it's simply 0 at the moment. So now I would like to do a few updates one by one. After each update, we would like to review what's going to be the printouts for the 2 local variables and the 1 global variable, right? To make it clear. Let's see the first one. What's going to happen if I say C1.increments local? Okay, so this is a mutator method call, right? We should be very familiar with that already. So now C1 is a context object, so now we talk about C1. Increment local, what does it do? If you go to increment local over here, it's going to do whatever context object is, in this case C1. So that is C1.L++, right? C1.L is over here, plus plus, so you'll go from 0 to 1. Agree? Okay. If we simply try to re-execute this block of code, I didn't do the copy and paste, right? Just imagine. If you do that, C1.L is going to become 1. Agree? C2.L is still going to be 0, it remains to be 0. And also counter.G is going to remain to be 0. Nothing has changed to the other 2. Okay? Hopefully that's clear so far. Let's do something very similar. Let's try another one. If I say C2.increment local, right? So which variable are we modifying right now, right? So now, again, you can look at the context object is actually C2 over here, right? So that means we're talking about C2. And when you talk about increment local method here, it's going to modify the local copy for that context object. So similarly, we're going to increment C2.L from 0 to 1. Okay, so now if we try to re-execute this block of code, what's going to happen? C1.L remains to be 1, C2.L has now become 1. And counter.G also remains to be 0. Nothing has changed globally just yet, but we're going to see that. Okay? So now let's have a look at 3 more lines. So the next 3 lines is going to modify the global variable. Okay? So now let's see that. First of all, let's see C1.increment global. What does it really do? Again, this one here, it's basically we are trying to call a method mutator on the context object C1. However, internally, what's going to be modified is not a local variable. It's going to be the global variable. Okay, let's see what's going to happen. So now the context object is actually C1. So C1 is over here, okay? What's local to C1 is only the L. However, when you look at increment global, it's going to execute this method over here, right? But over there, it's going to increment G. But G was declared as static, which means we're going to modify the shared copy of the variable. In this case, G, if you say basically C1.G++, okay, as we said, it's allowed but not recommended. So now increment G is going to go from 0 to 1. Okay, so this is how we update the global variable. So now after this, if we try to re-execute this block again, let's see what's going to happen. C1.L remains to be 1. C2.L remains to be 1. But now when you say C1.G, you're basically asking what's the value for the global variable. It's now just 1. It has become just 1. C2.G is also 1 over here. Basically, when you say C1.G, C2.G, you're referring to the same copy of the variable. Okay? And now finally, when you say counter.G, it's also referring to this particular variable, 1. Okay? Okay, very quickly, let's do the second one. The second one is very similar. If you try to do the second one over here, C2.increment global, basically you're going to re-execute this method again, but now you would say, basically, I'll put it here. You're going to say C2.G++, in which case you're going to modify from 1 to 2, right? If you re-execute this block of code again, you get the same idea, okay? So now C1.L, 1, C2.L, 1, C2, also C1.G, C2.G, they're both of them, simply just 2, all right? Let's do the final line. The final line is going to be the most common one you will see, okay, later. Okay, so we have no more quizzes for the course, but you might have the exam, so please make sure you know how to do the static variables, okay? Let's do the final line over here. let me use a different color here just to distinguish. Let's say we do, how about this? If I say counter.g is assigned to counter.g plus 1, okay? So now you can see this is the more common way of referring to the static variable. Over here, you can see that we are basically using the class name counter dot the static variable g, right? We're saying that we're going to reassign this particular variable over here by its current value plus 1, okay? So that means it's going to be 2 plus 1, which will be 3. So after this, what's going to happen? If we try to re-execute this block of code again, c1.l remains to be 1. c2.l hasn't been changed, also remains to be 1. What about c1.g over here? c1.g referring to 3 over here. c2.g also referring to 3 over here. And finally, counter.g also referred to here, also 3. Okay, any question about this? The method, yes. Basically, every time if you want to modify the attributes of the context object, you want to make a method call, right? To steal the dot notation. For the static attribute, you don't necessarily have to use a method call, but for this one, I'm just showing you how you can do it. What you could have done is just like this. How about this? Let me show you this. If you look at these two method calls over here, where we do have C1 and C2 as a context objects, versus this one over here, this is using a class name rather than context objects. So these two groups are definitely just equivalent. They're the same. They have the same effects. Basically, you're just referring to the global copy of G over here and try to increment it, right? But of course, in reality, you might do any updates as you wish to the static variable. You might say plus 1, you might say plus 2, you might want to say assign to some other value, right? That's something I would expect you to get used to just by yourself.
So after you use like the C1 dot global one, so already two object one point C2.
So basically, when you say C1.g versus C2.g, they are really referring to the same copy of the variable, the value, the same. Also, when you say counter.g, also refer to the same. No, don't think about you got two copies of the global variable. You only got a single copy, right? There's only one single copy that's over here. Only one single copy here, right? Yes? Good question. Very good question. Good, I like that. The question was, if I say counter dot increments global. Okay, let's say. Versus, if I say counter.g is assigned to something. Okay, let's compare 1 and 2. Number 2, we already know it will compile because we are simply referring to the static variable using the class name. But for number 1 over here, the question is, will it even compile? The answer is no. Okay, why is that? Okay, we wouldn't really go for static. Well, let's keep it simple for this course, right? For those of you who go to 2030 in the fall, you will actually learn about static methods. But for this course, we keep it simple. You don't have to worry about static methods. We only worry about static variables. So now, let me just mention the principle is the same. If you look at the declaration, the header for this particular, sorry, not this one. If you look at the header for the method over here, you say void increment global. You don't see the keyword static. That means every time you want to call this particular method, there must be a context object, as we said so far, right? However, in 2030, you can feel free to actually add static to the front of the method, in which case you can call the method by using the class name. Okay, but that's a little bit too advanced. Okay, but overall the answer is this will not even compile, simply because for increment global, it's expecting some context objects, but this is not a context object. But for this one here, it's just accessing the static variable directly, so that's okay.
What if you just attribute that place, if you just say static int g, then you call it what one?
Static int g, where?
And you,
Oh, in the counter class? Oh, are you trying to say if this line over here, okay, you're talking about this line here?
yeah, what if you erase?
Sure. Basically, the question is, let me try to find a space. Let me put it on top, okay? We got some little space here. You're asking, what if I simply say static integer g, just like that? It would be okay. I'm just saying it's more common that you try to initialize the static attribute right there. It's just more common. However, if you do this, that means it's uninitialized, which will get the 0 value, right? Okay. Every time, if you got any variable that's uninitialized, you'll just keep the default value. The principle is the same. Okay? Okay, guys, any question about static versus non-static? Okay, so now we should be ready to do your practice test, right? Remember, if you recall, what's required by the practice test about a coffee shop? Basically, every member in the coffee shop, they have a unique ID. For example, member 0, member 1, member 2, member 3, etc. It will just keep incrementing. However, when you first create a member object, you don't actually want to pass the number as the arguments. I'll show you, don't worry, I just verbally mention that quickly. So we want to have a better way to manage that. Okay, let me show you what I really mean by this. If you look at the slides, it's going to be slides starting from slide 67. Okay, so now what we want to do, let me just show you some code over here and then we'll trace it. We really want to see how we can move from using non-static variable to manage the ID to the static variable to manage the ID. The latter is the solution, okay? Let's see. Now, let's look at this fragment of code. We got a count over here. So you can see we got a non-static ID. And then we got string owner, only 2 attributes. And then every time if you want to create an account object, you have to give, when you create an object, some ID over here. Maybe for the first object, I'm going to pass 1. For the second object, I'm going to pass 2, etc. Right? And then the owner. Okay, and a very easy initialization over here, as we said. So now what we want to know is, how would it work, let's say without a static, how things will be managed. If you look at the tester over here, okay, very quickly, and then I'll trace it together with you. You can see basically the way we use it, let me just switch to iPad now. Okay, the same block of code over here. Again, you can see this is non-static. This is also non-static. Okay, you don't see any static keyword, okay, just to keep in mind. So now the way you create the account is by passing as one of the arguments 1 and 2. You have to manage the IDs yourself when you try to test it. Okay, so how does it work? When you when we try to execute this line over here, we're going to say ACC1 is actually going to point to some account object, I will say ACC here. Every account has the ID and also owner, right? And now we say that ID should be 1, owner should be Jim. So we put 1 and Jim over here, okay? And for the second one, we're creating a second account object over here. And then we say ACC2 is pointing to just another account object. So now let's see what the input arguments are. The input ID is now 2. So that means the ID will be 2. And also the owner will be Jeremy. Okay, that's how we manage that. What's the disadvantage for this approach? It seems to work because now, if you try to check ACC.ID, or sorry, ACC1.ID, it will be 1. When you try to check ACC2.ID, it will be 2. They seem to be unique. The solution works, but it's very error prone in the following sense. Every time when you actually create a new object, you have to pass an ID by yourself when you create the objects. And you want to make sure you never repeat the numbers. What if you make a mistake? If I made a mistake by doing the following, rather than passing 2 over here, I pass simply just 1 accidentally. In that case, I'm going to have 2 objects with the same ID. So that's not good. Okay? So now this first approach might work, but it's very it's manual completely. It's very prone to errors. We want to get away from that. what we really want to have is the following. We want to say every time when you create the account objects, we don't actually want to pass these integers. We want the object itself to maybe manage this for us, which means there should be somehow global counter that is going to increment maybe every time by 1 when we create a new objects. Basically, that's what we want to do. So now we already learned about how to make a global counter. We simply just declare a static variable, right? That's what we just learned in the previous slides. So now we will see how we can use a static variable to really move from this solution here to the final solution, okay? Let's have a look at the code very quickly. So that this solution, again, it works, but it's not very easy to maintain. Okay, now what about the second one? The second one over here, okay, so we got a count class over here, and then you can see that we have the integer over here, which is static. Okay, you can see we're using the word static. What does that mean? That means we are maintaining a global counter over here that is going to be only a single copy for every object of type account, just a single copy, right? The initial value for the counter is just going to be 1, okay? And then we also got non-static attributes over here. We got ID and we got owner, okay? So these are the two non-static attributes. And then we got a constructor over here. Notice what parameters we have for this constructor if you compare. In this version over here, we only got one parameter, which is just the owner. In the previous version, if you look at the account, we actually got two parameters. We got the ID over here, and also we got the owner. Okay, so they're different. So that is why the second version will be better. Because for you to actually create a new objects in the second version, you don't have to worry about passing the ID yourself. Okay? How is the ID maintained internally? So that's something we want to trace in details. Okay? Let's just go over the code very quickly over here. Basically, if you look at the contents for the constructor here, we simply say whatever ID it is for this current object being created, it's just going to be the counter value globally. Okay? And then we're going to increment the global counter by 1 so that the next object creation is going to use a different counter value. Because every time you add something, you add 1 to a value, it's going to give you a different value, guaranteed, right? It's a very simple mathematical property. And then finally we'll say this owner is assigned to owner. But now, how do we trace it? That's the tricky part, right? Let's trace this together. So now this is same block of code. So we got two classes over here. We got account tester. Okay? We got two classes over here. So now you can see that the way, first of all, let's notice the immediate difference. When we try to create ACC1, when we try to create ACC2, the constructor over here no longer takes any 1 or 2 as previously. Previously we had to pass the two numbers, but now we don't have to anymore. Okay? That's a first difference. But now let's try to trace exactly what's going to happen. Okay? So now let's do this. Let's try to trace the first line. Okay? When we say ACC1 is going to assign to the address of this particular new object over here. Okay? Let's draw that. So now ACC1 is actually going to point to a new object over here on the memory of type ACC. Okay? Account. So now, how many attributes should we include in the diagram for each individual objects? Well, apparently we got one variable here, we got two variables here, we got 3. Should we include all the 3? No, just 2 of them. So what we'll do is we're going to do ID, which is non-static, and also we got owner. Okay? Only these 2, non-static. And then what we will do is we're going to assign the owner, which is Jim. Okay, I'm going to ignore that part, omit the detail for that part. You know how to assign that. So now here comes the tricky thing. When we try to execute the constructor over here, how exactly this line is going to be executed? That's the critical part. Okay, let's see that. Since we got a static variable over here, okay, I'm going to use green. We're going to keep it aside to keep track of it separately. So that means we have a place for the global variables. So this is for the account. Okay, or the static variable. In this case, it's global counter. Okay, I'm going to put it here. Global counter. The initial value is simply just 1. Okay, so far so good. So now what we want to see is exactly how this line is going to be executed. Let's do one by one. What about this part first of all? When I say this.id is assigned to global counter, what's this? This is the EECS1021 I'm trying to create at the moment, right? When you say the ID, which is this field over here, is going to be assigned to the current value for global counter. In this case, it's simply just 1, right? That's how we assign the value 1. After that, we're going to increment the global counter over here. Okay, how does that reflect on the diagram? You're going to basically increment this copy only from 1 to 2. Okay, you can see now after executing these two statements over here, what we have is this. The global counter has changed from its initial value from 1 to 2. And then you have the local copy over here, 1. Okay? So now let's see what's going to happen if we try to execute the second line to create the second object over here. Okay? So now for the second one, how do we create EECS2? Let's see this. What's going to happen is we got EECS2 is pointing to new account objects over here. Okay? Just another account objects. Okay? And then we have basically, again, two attributes for the account objects. We got ID and also we got owner. For this part, we know owner is going to be just whatever the argument value is, Jeremy. Okay, that part is okay. But now we're going to execute the constructor for the second time. Now, how do we execute the two same statements over here? Okay. So now when I say this.id is assigned to the global counter value, what's this at the moment? This is now the context object has changed to EECS2. So EECS2.id, which is over here, is going to be assigned to global counter value. And now it's going to be 2. After that, I'm going to increment the global counter over here by 1, which means it's going to be incremented from 2 to 3. So now we have another object being created. After this, what does that mean? You can see what we have achieved over here. Basically, you can see for the first object, the ID is 1. For the second object, the ID is 2, so they're unique. And also, the global counter over here has been incremented so that it's ready for the third object to be created. So this approach will just work automatically. Okay? Any questions? Guys, if you got questions, it's now time to ask me. Okay? Okay? Static variables sometimes can be a little bit tricky because you got to mix together with non-static variable. But as I said, the best principle for you to remember is static is simply global. You have to keep it aside to keep track of. But for non-static, each object has its own copies, like how we said before. Okay? And this is just one of the examples I would like to talk about. Okay? And this should be sufficient for you to complete the lab test, the practice test, okay, that I gave to you. Okay? I think that's the only part where I didn't cover in the class. But now since we covered that, you should be ready to do it. All right? So now, I would like to give you a little challenge over here, okay? And this is a kind of a question I would like to ask in the exam. So now, I want to show you this. Okay, for the rest, you can simply just go over. Let me just go back to the slide. Okay, good. Now, I want to apply the static variable in a different context. Okay, now rather than managing the ID, remember what we said last time, also in this week's tutorial video. We are basically saying your attribute, let's say your student class. The student class store an array of course record, and also we got an integer counter, number of students, sorry, number of record, NOC, right? Number of courses. So now, if you recall what's happening in your tutorial video, the way we declare the counter was we simply put it as non-static. Think about what's happening in your tutorial video, okay? In your tutorial video, okay, let's see, how low should it be? Okay. In your tutorial video, this is what you would have done. You would say class, I got clients, and then we got accounts, and then we got accounts over here. And also, it should be non-static, right? If you remember, number of account, let's say. This is what you would have done in the tutorial, right? Now I'm giving you a challenge over here. What if I add static to the front? Would it work? That's the question. I will give you a little bit hints. You better think about this right now, okay? I'll definitely go over the solution together with you, but I'd like you to think. Now, we're going to change the type for this particular counter. In the tutorial, I say it should be non-static. Actually, in the tutorial video, I never talk about the concept about static versus non-static. But since now we know, we want to know which version will work. It could be both, right? So now the new version over here, integer number of accounts, I'm simply declare that as static. So that means all the objects of type clients is going to share the same copy of this counter, okay? And then over here, the way we add a new account is just the same as it's taught in the tutorial. We simply say account should be account at position NOA, a number of accounts, should be assigned to the object and then increment the counter. The same as before. But now we want to know if the runtime behavior is going to be different. Okay, that's something we want to find out. I want you to look at specifically. Okay, these 4 lines are very easy. We simply create a new account called Bill and Steve. Oh, sorry, we got 2 clients, Bill and Steve. And then we try to create 2 account objects, ACC1 and ACC2, right? And now these are the 2 important lines to look at. Line number 1, we want to add ACC1 into one of the accounts for Bill. And then we want to add ACC2 into one of the accounts for Steve. Presumably, after these 2 lines, each client should have exactly 1 account, right? Bill has only ACC1, and Steve should have ACC2. And according to the pattern we have learned in the tutorial video, where should they be stored? Index 0, the leftmost position, right? But now, would it be the case anymore? That's the question. Okay? Why don't you think just for 20 seconds, think about what's going to happen. Are you going to get array index out of bound exception? Are you going to get null pointer exception? Or it will just work? Okay, I'll give you another few moments to think about. The best way to really solve it is by tracing it. Okay? So this example is really nice because it will really further strengthen our understanding about static versus non-static. Okay? Let's see exactly how that will work. So now this is how we're going to draw. Okay? Again, visualization is really important. First of all, we're going to create 2 clients. Okay, we're going to get Bill and Steve. Let's draw them very quickly. So Bill is going to point to a new client's objects over here. And so now, how many attributes should we draw in the picture? Should be just 1, not 2 anymore, because now this is static. It should be global. Okay, so what we will do is we're only going to put accounts. Okay, which is just going to be an array. You can assume the constructor is going to initialize an array of certain size. Let's say size 5, just make it easy. So now it's simply just going to initialize an array of size 5. 0, 1, 2, 3, 4. Every slot is simply storing null. Okay? And then, because this particular counter over here is simply static, we have to keep track of that separately. So what we will do is we're going to keep it over here. Okay? So we're going to have clients, the class over here, and then it's called number of accounts. I'll say NOA just for short. Okay? Number of accounts is static. Initially, it's just going to be 0. So now, this is what happened after we created the first object, right? We got accounts over here being local, and we got an NOA, number of accounts, being global. Okay? Let's do one more. What about creating the second client? When you create a second client, it's going to be Steve, right? So now we're going to have Steve. And now we also got clients over here. And now, again, the only variable we have being non-static is simply the accounts, okay? So now if we have accounts over here, which is also going to point to an array of some fixed size, 0, 1, 2, 3, 4, okay? Every slot in the array simply store now, okay? Now, we want to see two more things, okay? So now what about executing these two lines? So these two lines are simply just going to create two account objects, okay? So what we would get is, let me put it here, ACC1 and ACC2, right? So let me say ACC1 is going to point to some account objects, okay? And then also ACC2 is also pointing to another account objects, ACC, okay? These two objects, okay? Here comes the important critical moments, okay? If I try to execute, let's say this line over here, okay, what's going to happen? When I say bill over here, that's the context objects dot add accounts ACC1. Okay, what's going to happen? That means I'm going to execute this block of code with the context objects being bill. What that will do is you simply say, okay, I'll put it here. You're simply going to say bill dot accounts at position the current value for the static variable, which is NOA, right? NOA is assigned to, in this case, we're trying to assign ACC1. So that'll be ACC1. And then after that, we're going to increment NOA by 1. Okay, let's see exactly what's this is going to happen. NOA at the moment is actually simply just 0. So what we will do is, so now position 0 of the array is going to point to over here. Just like that. Okay, that's what we have. And then after that, we're going to increment NOA by 1. So that means it's going to go from 0 to 1. And notice that the NOA over here is static. Okay, it's global. Okay, that's different from your tutorial videos. But what we want to illustrate, this may not work as you expected. So now, so far it's okay. Because we have only added one account, ACC1, to bill. And it's stored in the leftmost position. That's not a problem. What we want to see now is the second one. The second one might be problematic, right? One intuition. Because we're going to execute this block of code for the second time, it is going to use a current value for NOA, number of accounts, which does not start with 0 anymore for Steve, right? It starts with 1. Because that has been incremented previously, okay? So what we're going to do is we're going to execute these two lines of code, and then I'll write it down exactly what's going to be executed. It's going to be basically Steve dot accounts, the current value for NOA. As we know, the current value for NOA is 1 rather than 0. This is assigned to, and we're trying to do ACC2. ACC2. That's the first line over here, okay? And the second line, we're going to increment NOA plus plus. So now, how do these two lines execute together? What we will do is, we're going to go to Steve.accounts. Steve.account is referring to this array over here, and then go to position 1, which is exactly over here, which means we're skipping position 0. And then we're going to say ACC2 is assigned to that particular slot. So that means this slot over here is going to point to ACC2. And then after that, we're going to increment NOA, so from 1 to 2. So that means if you try to add another account, it's going to be added to position 2, right? So this is not really working because you can see that after the first insertion is 0. After the second insertion is now 1 rather than 0, okay? The main reason is this static keyword over here. Apparently that's wrong. Okay? So there are two lessons to learn from this particular example. Number one, you shouldn't use static for this particular counter because the counter that we taught you in the video should be specific to the context objects only. It should not be global. That's number one. Number two, if I do give you this question here by using static rather than non-static in the exam, you should know how it behaves. Okay? I might give you something similar as well. So that is why I say previously, when you review the tutorial videos and the slides for the exam, number one, you want to do it early because our exam is only 3 days after the last class. Okay? Number two, when you review them, you want to pay more attention to how I illustrate the logic for every program. Either they work or not work. That's the best way to prepare. Okay? Okay, any question for this example here? Any questions? Okay, I got just a few more slides to mention quickly about static. Okay, quickly. Okay, but now up to now we cover everything you need for the lab test. Okay, for next Monday, possibly I will just talk a little bit more auxiliary stuff for OOP, especially how you define helper methods. That's not really required for your lab test 3, so you don't need to worry. Okay, everything you need for the lab test has been covered. Anything that we cover next week will just be like a review. Okay. So now that's the first common error we might have. Let's have a look at another common error. Okay. This part here is simply to show you how you can fix it, right? The way to fix the error is by using non-static rather than static. Okay. So now we want to see another interesting common error. Okay. For those of you who actually might be a little bit more experienced in Java, I'm pretty sure you run into this error at some point. Okay. Basically, once we introduce the idea about static, whenever you want to mix the use of static versus non-static, you want to be careful. Okay. Otherwise, the compiler may not be happy. Okay. I want you to look at this fragment of code very quickly. Okay. So let's say we have a class called bank. Okay. And then we have a non-static attributes branch name. What does that mean? That means every bank has their own name. Maybe the CIBC in North York, maybe the CIBC in Macau, for example, right? And then we got over here, so this is the static attributes counter, right? There's like a global counter we just talked about. So this is static. And now, actually that goes back to your question here, using static method. We do have one example over here. That's the only one I will cover. If you look at this particular fragment of code, starting from line number 4, when we declare a method to be static, let me emphasize this. In your lab test 3, you should never ever use a static method. Okay? The only occasion you might use a static is by using static variable for the counter. That's the only occasion. The reason I'm showing you this static method here is it might be covered in the exam, but not for the lab test 3. Let me make it clear. Okay? Don't get confused. Now, if I have the static method over here, okay, over here, and then I say user account number, okay, and now line number 5 and number 6, what am I trying to do? And basically, you can see line number 6, I'm simply trying to increment account number, just make it unique. In line number 5, I'm trying to print out a branch name, okay. This might still be very advanced, so that's something you want to get over before the exam. Is this fragment of code going to compile? I'm just talking about compilation. Okay, I forgot to put it on my iPad, but I can do it right away. If the Wi-Fi works. Let's see if that works. Okay, it should work. Okay, that's the fragment of code we just looked at in the slides. So now I want you to look at this class very carefully. Number 1, does it compile? How about I give you a hint? It does not compile. Okay. Question number 2, which line does not compile? Which line? Well, I can tell you that line number 1, 2, and 3, and 4, they seem to be okay. Okay, nothing wrong with that. It's really to decide either line number 5 wouldn't compile, or line number 6 wouldn't compile. 5 or 6. Okay, let's see over here. I will give you a little bit hints over here, okay? Because we are getting there, okay, I'll use 1 minute to give you a quick hints. The fact that we declare this particular method to be static has the same consequence as static variable. That simply means when you try to use this particular method, you don't necessarily have to use the context object to call that. For example, I can simply say bank, the class name, dot, use account number. This is expected because this is static, so I can simply use a class name. Okay, that's a hint to you. Given this hints, so here we talk about how you define the static method. Here we talk about how you use it. But there is some inconsistency over here, either in line number 5 or in line number 6, either way. Okay? It turns out line number 5 is the error, right? Branch name over here is basically referring to the branch name over here. And you can see that that one is non-static. When it is non-static, what does that mean? That means if you want to get access to the branch name, you must have a context object, right? But branch name, let me write it down quickly, okay? Branch name is non-static, which requires a context object. A context object. But now, if this can be accepted, there's no context objects, right? But this is not a context object. So now these two things actually are inconsistent. Let me recap very quickly and I'll let you go. Under this particular static method here, which can just be used by passing a class name rather than any context objects, we are referring to a variable that's non-static, which always requires some context object. For example, you might say b1.branch name, right? That's always required. However, if we allow this to happen, that means bank will just be used as a context object. No, that's not going to work. Okay? So what you will get in Eclipse, if you try this, is going to say the following. A non-static variable used in the static context. This is what you will see in Eclipse. When you first see this error message over there, it may not be very informative, but the best way to understand it is to think about how you will use a static method by just using the class name. And that one there is simply just going to make the reference to this particular non-static variable not working because you always need a context object. Okay, I'll continue from here from next Monday.